So a couple of you have already said, hey, I don't understand this. It's too hard. I don't understand how you got what you got. So what I'm going to do for this video is I'm just going to go through and we're going to talk about and pull out the triangles and talk about what it is that we need. I'm not writing the formal proofs. One of the kids from 7th period was working on it during Stinger today. He's like, I'm on step 10. So notice that it asks you to get a separate piece of paper because there's really not enough room to prove these on this worksheet. This is more about just a place where we can write down all of our ideas. Now I got to tell you something, there's more than one way to go about these. So I'll talk about a bunch of things at the same time. You get to choose which way makes the most sense to you. All right. Step 1 in dealing with these proofs is to talk to your diagram. Once I know that P is the midpoint of QN, this P is the midpoint, and I talk to my diagram by going ahead and marking that up so I can see that that's true. If they tell me that MP and QN are perpendicular, then I know these are right angles. Now later on in my proof, I'm going to have to talk about how I know what I know, but for now I'm just talking to my diagram. All right. Good old reflexive property never fails. So do you see right away the two congruent triangles? Does everybody see them? Okay. So the first thing that I want to think about is that I can have triangle MQP be congruent to triangle MNP. And if those two triangles are congruent, they're going to give me all of the corresponding parts. So let's think about what it is that we're trying to prove. We're trying to prove that triangle MRQ, that's this one here, we're trying to prove that he's congruent to this guy here. So, can I pinch anything that's going to help me in that conversation from this triangle here? What can I pinch from CPCTC? What can I grab? Which side? Yeah, this hypotenuse. Good vocabulary. Thank you. So this side here is going to be congruent to this side here. So I'm going to have those two purple sides congruent. So that means that MQ is going to be congruent to MN. Hey, that's one of my sides of those triangles I'm trying to prove congruent, right? Any other things I can pinch from CPCTC? Yeah, so check it out. I can grab this hypotenuse, but before I can grab this one, I have to talk about these little triangles being congruent. So if you want to use that one, you're going to have to talk about triangle QRP being congruent to triangle NRP. Because then through CPCTC, you'll be able to get QR congruent to NR, right? So if I have that side congruent to this side, what's left? Yeah, side, side, side. Now you're going to have to go back and state specifically that MR is congruent to MR. So MR being congruent to MR is again the reflexive property, but notice that's not the same as MP being congruent to MP. So you do need to take the time to talk about the difference between MR and MP. And then you can get side, side, side congruence, and you're good. Hey, did anybody else wonder about these angles here? Would those be part of CPCTC too? Yeah? Sure, right? That way, and then you wouldn't have to do the second triangle. You can just go ahead and use those angles, and then you can have side, angle, side congruence. More than one way to go about that guy for sure. All right, are you ready for this one? If I'm given that the distance from M to P is the same as the distance from Q to O, I'm also given these angles here, or those sides there. So because they are isosceles sides, I get those base angles. Now, for this triangle especially, it's super important that you figure out how to draw it separate. So I'm going to try to do that one more time because I want to pull it out. Let's see if it's going to let me do it. Oops. Okay. So there's that triangle. And then if I want to talk about this triangle, then I can pull this one out. So think about these two triangles. This one was NMP, and this one was OMQ. Now keep in mind what information I already have. This is congruent to this because of my base angle theorem. This is congruent to this because it's given. And guess what? This was also given. What do I have to do to prove those two triangles are congruent?
Side angle side.
Yeah, nothing. Because the side angle side, like Philip said, is already given to me. So my first idea is side angle side is going to give me the fact that triangle NMP is congruent to triangle QMO. So now I got those two triangles congruent. What can I gather through CPCTC? What am I going to get? You're going to get everything, right? You're going to get everything. You're going to get that M is congruent to, that this angle here is congruent to this angle here. And you're going to get that this side here is congruent to this side here. If I'm trying to prove that triangle MOP is isosceles, I got two ways of going about it. If I have these two sides congruent, that's going to make it isosceles. If I've got these two angles congruent, that's going to make it isosceles. Notice I have them both. So whether you choose to talk about the congruent base angles or the congruent sides through CPCTC, you're going to get sides and angles to prove that triangle MOP is isosceles. All right, let's check out the next one. Given the diagram, FG and EH are parallel. All right, so if I have these two segments parallel, let's go ahead right now and talk about our alternating interior angles. So our first consideration is our alternating interior angles. Now my goal is to prove that FEM and GHM are congruent. I'm talking about these two triangles here. Let me ask you a question. What kind of triangle is FGM? How do you know? So triangle FGM is isosceles. So that's going to give me these, right? Talk to me about triangle EMH. What's that? That's also isosceles, thanks to these angles. And I got those angles by alternating interior angles because the lines are parallel. Where do you think I'm going with this one? Where am I going to get the angle? Side angle side, once I have my vertical angles. So I can go ahead and get side angle side congruence from all those little bitty triangles. So as you're exploring these proofs, pull the triangles out, mark up what you have, use this sheet for ideas, and do your formal proof on separate pieces of paper.